For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
So they look to molecular clocks and DNA function. That's why the ALUs you talk about, or the ERVs, for example, the fact that they're highly functional DNA elements, that's certainly consistent with this model of, as you love to hear me say, created heterozygosity.
When
How do you
can we
explain that?
expect Adam
I'll
and
ask
Eve's
this one last
genome?
question, then you go back, and then it'll be your turn. How do you explain the functional roles found in these? I like to call them variation-inducing genetic elements. You'll say they're ancient remnants of viruses and parasites, but how do you explain the function?
What do you mean? How do I explain the function? Which one did you have in mind?
Okay, so if we're looking at, for example, why don't we look at endogenous retroviruses?
Okay.
So we know that they are that they're playing important roles in determining.
You admit they're viruses, right?
Well, I would say I mean, like I said, I call them variation-inducing genetic elements based on their function.
Yeah, but are they viruses?
Well, I mean, we know that viruses, for the most part, within us are beneficial. We have more viruses than we do bacteria and cells. So point is, are they created units of DNA as we would predict? And I would say that the evidence does suggest it. Now, you probably looked at the several papers that I had screen
Not
shared.
yet. I don't have the screen up to where I can see what those are.
Oh, you didn't see okay, so I had those screen
Well,
shared.
believe it or not, it's very difficult to just copy crap off that I see flit by at 900 miles an hour.
Okay, well,
let me ask you this. You had all this information.
Answer the question. I could go on and on with these papers. I'll just read one line and then have you explain it. So this one says ERVs frequently act to distribute regulatory information and thus confer genes with new patterns of expression and function. So for example, would your argument be, okay, these ERVs that have crucial functions in regulating genes, determining cell types, they were co-opted? Like, do you have an original thought of your own, or is you just going to go with the author's conclusion?
I'll go with what the scientists say on it. It's their field. They're the ones with the PhDs. They're the ones with the actual pedigree. Are you going to override them because you have a dogma involved?
Okay.
As far as I can, let me ask you a question. As far as I know, all the endogenous retroviruses are called retroviruses because they start out as viruses, not as some originally created design thing. Now, if you want to present a monograph that establishes that the virus quality of them isn't in fact a virus, we look forward to your monograph on that, and don't just try to against it.
I appreciate you saying that. That's why I said the question is, are these really the remnants of ancient viral infections or ancient parasitic infections and invasions, for example, or are they created units of DNA function? This is what I find funny, RJ. Okay, I'll ask you two questions, and then if you want, you can go on to asking me questions. I appreciate that this is a little more respectful. Okay, so there's a class of retrotransposons. If you've seen my debates before, I've asked this before, maybe you're prepared for it. So this certain class of retrotransposons is found in the mouse embryo. Now, if you deactivate it, the mouse embryo will develop, and then suddenly it stops. Well, why? It's because it depends on the function of these retrotransposons, which evolutionists used to say were non-functional evolutionary leftovers, and supposedly these functions were co-opted. If that's the case, were mice just not having kids for millions and millions of years? How would you explain that? If these mice need these retrotransposons for development,
who says
that's evidence of DNA.
It's the whole point is that lots of retroviruses, ALUs among others, can take on functionality. The question is, do all of them do that? I have a paper as well that I was just looking up today. Infection by porcine endogenous retrovirus after islet xenotransplantation in SCID mice, where they were establishing that we need to worry about a lot of pigs as organ donors and others, because there are retroviruses in there that when transplanted into mice can take on their old viral functions and do bad shit. Well, it's perfectly understandable that such things
wait, slow down. Repeat that last part. What did they do? Was that
designed?
Well, wait a minute. What did they do? They implanted a virus into the mouse embryo?
They took the elements of the pig and transplanted it into without any modification, and it takes on its old viral function again.
What was the viral function? Something negative?
A lot of viruses. Well, from the virus's point of view, it's all positive. But
right
for us.
But I mean, so could you, and you don't have to do it now, do you have any papers, and we don't even have to, it doesn't have to just be the ERVs, it could be any class of retrotransposon, any signs, lines, whatever, ALUs. Do you have any paper that actually shows empirically that a non-functional, whether it's an ERV, whatever, went from non-functional to functional? And then I can look at that and see, okay, here's.
Erica said you would bring that up.
But I'm also not a geneticist, and that's not really my world. Yeah, I'll be the first one to admit that I'm not a geneticist.
Again, I'm not a geneticist. Genetics is not my forefront.
Because I'm not a geneticist.
Again, not a geneticist. Then I'm not a geneticist. So I'm not a biochemist.
I'm not a geneticist.
And I'm not very well versed in genetics.
Fine, because I got my notes right here, because I don't know enough about genetics.
Again, I cannot emphasize enough how this is not my field. As I've continued to kind of begrudgingly admit throughout the course of this conversation that genetics really isn't kind of my field. I can talk to you a lot about, other stuff that genetics isn't it. I don't know about because this isn't my field. Genetics really isn't kind of my field.
I'm not a geneticist.
That's not my field. I wish I could give you a better answer. I can't give you great answers because I don't know them.
Oh, idiot.
So what was the answer she told you to give me? Because if they're accomplishing crucial functions in regulating gene expression, differentiation, and development, I want to see a paper on how these functions can actually be co-opted. Because it seems like the evolutionists, and unfortunately, RJ, it seems like you've lost one of your favorite pieces of evidence. So would you have a paper such as that?
That's the argument we go into, and this was not going to be a program on endogenous retroviruses, so I'm not prepared for that.
Okay, but
I don't have that at the top of my thing. This was about human evolution, Adam and Eve and Noah, and I've been hoping to get onto that world. The reason why I brought the subject up, in fact, was that nobody in the creationist worldview has thought about this matter of the population of the new world. And this new paper of Jensen, I'm going to be really wanting to see whether he does any better on that. They don't bother thinking through all of that because the people who wrote the Bible didn't give a rat's ass for anybody out of their framework. All of that stuff didn't exist. They didn't even know it existed. So there was no framework for them to go on.
But here's what I find weird. You asked John, you've asked multiple creationists, and that's why I was excited to have this debate. You asked Adam and Eve, were they created with ERVs, ALUs, and these classes of retrotransposons? And now that I've cornered you on the topic, you're saying you're not prepared. Well, why did you ask?
I will go on at that issue about whether Adam and Eve had them. Do you know anybody, Jensen, Tompkins, Carter, Sanford, who has laid out what the original genomes of Adam and Eve needed to be in order to account for the heterozygosity of the hypothetical Noah and the kids, let alone all of the current ones? It's only 6,000 years. That's not that long ago. That's a relative snap for paleogenomics tinkering with that short of a time frame.
What was your question? I was actually just talking to Jensen the other day about these variation-inducing genetic elements, the ALUs, the ERVs, and I was asking him, how many of these do you think were created initially in Adam and Eve? But the fact is, and he directed me to a paper, a really highly technical paper that I can pass on to you. But the fact that these are all functions.
And was that by a creationist or a regular science paper?
No, this one would be from Dr. Nathaniel Jensen. But the function is key. DNA function, molecular clocks. The function I've showed you that, well, I mean, for one, if viral DNA is inserted, as you were talking about, at random into the genome, and that's why I asked you if that change in the paper you were talking about was negative, it's more likely to disrupt existing genes. I told Conspiracy Cats this. I said if a blindfolded painter, he's going to most likely mess up the painting he is working on just by applying random brushstrokes to it. So these functional roles, there's no paper out there that shows them being co-opted. Therefore, we can safely say that all of these retrotransposons.
The reason why I bring up ALUs is that the vast majority of the ALUs that become functional are disease causers.
Okay, of course. I'm really glad you brought that up, actually. So, well, the ALUs are a little bit. That seems to be your expertise. So, we'll stick on that. We'll stick on that there. So these ALU sequences, they're what? They're small repetitive elements representing how much percent of our genome? 10%. 10%. Now they have the ability.
1.4 million of them and counting.
How much?
1.4 million of them and counting.
Okay. Now, because of from the papers I've read, and I've read a few over the last week, and it seems that they always assert, so they'll say in these papers, and once again, I'll pass those to James, they say because of their ability to move around the genome, these jumping genes are considered as real motors of evolution. That's all they say, considered as real motors of evolution when going over the functional roles that they have, because they talk about how the ALUs can allow cells to adapt to stress, for example, during viral infection. But like you said, they lead to disease. Well, that's what we would expect, James. If they're functional DNA elements and they're mutated, for example, or something negative happens to them, of course they're going to lead to disease. Would you expect it any other way?
Yeah, so when exactly would the first disease-bearing... the reason why most ALUs don't do a damn thing is because they don't have a README code. That's why they're functionally invisible, and that's why they can replicate. That's why there's so many of them. That otherwise we'd be up shit creek. A few fitted into our brain chemistry. That's one of the notable areas where they took on a functionality. But most of the time, they're gumming things up because they're gumming up protein sequences. Now, is it a design defect of the designer to have put in a system that has a copy me signal like that just runs amok? Can we sue?
Well, I would say that copy me signal, those duplications assist in what I've been saying in variation. These are variation in inducing genetic elements. Is it reasonable?
Causing diseases.
Of course.
So the designer was okay,
RJ,
with causing diseases.
But DNA repair mechanisms, DNA redundancy, for example, requires forward thinking. And I asked Erica that question: how does natural selection, which sees the short term, not the long term, how does natural selection evolve something that requires forward thinking? How does natural selection evolve?
I think you may have an odd idea of what forward thinking applies in this case, and we're kind of far away. We use stipulate that no creationist has worked out what Adam and Eve's genome was. Is that correct?
No, actually, I'm going to send you. So Dr. John Sanford and Robert Carter are working on it. I think they've actually,
but they haven't done it yet. Is that correct?
Well, it's a work in progress. We understand very little of.
Is that going to be like Chadwick working out the paleo world? Is that a coming attraction that's never going to come?
I do want to answer that question, but I want you to answer this. Is it reasonable for us, RJ, to believe that these so-called ancient viruses and ancient parasites, the ALUs, possess the genetic information necessary to promote so many genetic functions and so many biochemical functions in human beings?
I don't accept your supposition. What about ALU do you think is like forward designing?
No. Well, you were saying with the mutations, for example, you're saying is this a DNA error, or is this an error in the design? Yeah, that's what you said. Sorry.
Mm-hmm. So you don't allow errors in design, right?
Well, obviously, if Adam and Eve were created with perfect genomes with pre-existing functional DNA differences,
right. You do not allow imperfection of design in principle. Is that correct?
We see defect. Like, for example, my car coming off the assembly line was near perfect. Now the air conditioner is broken down and rust is building up on the car. But
which means, as I said, you do not conceptually allow for imperfect design in principle. It's a standard creationist. I don't know of any anti-evolutionist that.
Yeah, but you're familiar with genetic entropy, RJ. We don't have to go down that route. I've said this before, so you're kind of, this is going to be a rabbit trail, but we accumulate 100 new mutations per person per generation. Take that accumulating mutational load back to a point of least mutation accumulation load. That's a point of perfect genetics, Adam and Eve. So yeah, after the fall, mutations have been introduced into the genetics of people and species. And now these ALUs, these ERVs, if they're subject to mutations, that will result in, of course, disease. But before we end, you asked me, have they worked out the original genomes?
Yeah.
Okay. Well, that's why I went over I didn't have time with you, but I've asked before. They're looking at, because we know human chromosomes are made up of relatively large linkage blocks. And Dr. Sanford, and you can look at this in the HapMap data, they're looking and analyzing these original text strings. And it shows us that the genome is young. Why? And then I'll let you respond. Because the genome has only been partially scrambled. When in fact, RJ, crossovers and gene conversions should scramble all linkage blocks quite quickly in an evolutionary time frame. That's a huge problem for you. Answer that question, and I'll tell you how they're using that data to come up with the original.
Who says that that's the problem? Is it stuff that Sanford says it's the problem, or do you have a regular scientist that says it's a problem?
Good question. Regular scientists, and they have explanations for it. Do you know what the explanations are for it?
Oh, well, summarize it, because right off the bat, I guess so. You summarize in the way that you didn't summarize Ventura's paper. Summarize this one for real.
Well, I did summarize the Ventura paper. They say that the sequences have been lost due to deep time dependency did it.
Oh, okay.
As the evolutionists would say, God did it. Okay, well, real quick before we end. So they're looking at those linkage blocks, and since they're still so large, that means there hasn't been much gene conversion or recombination going on. They can actually determine the original chromosomes, the original linkage blocks, and they're doing phenomenal work in it. And Dr. Jensen's looking at it through mitochondrial DNA differences, and they're close.